Okay, let's look at question number 9. For this question, it asks for the greatest 3-digit positive integer n, for which the sum of the first n positive integer is not a divisor. Take note, is not a divisor of the product of the first n positive integer. Therefore, in this case, let's look at the sum of first n positive integer. Positive integer. That will be just equal to what? That will be just equal to 1 plus 2 plus 3 all the way until you get n, right? And that is just equal to n times n plus 1 divided by 2, right? And then let's look at the product of first n positive integer, right? Can you see that this would be just equal to 1 times 2 times 3 all the way to n, right? And we have this notation called n factorial. N factorial means it's 1 times 2 times 3 all the way to n, right? Okay, we consider this case, case 1. Case 1. When your n, which is greater than 1, and n is odd. And n is odd. That means in this case, assuming that n is odd, then in this case, let us look at this division. That means in this case, can I divide? Can I divide n factorial? I divide n factorial by n times n plus 1 divided by 2. That means the product divided by the sum. And can you see that n factorial can be expressed as n times n minus 1 factorial. And this would be n times n plus 1 divided by 2, right? Or then can you see that your n and n cancel out? You will get n minus 1 factorial divided by n plus 1 divided by 2. Okay, therefore in this case, take note. Can you see that n plus 1 is definitely even, right? It's definitely even. And in this case, can you see that n plus 1 divided by 2 is an integer, obviously, right? Is an integer. Can you see that it's an integer that is less than n minus 1, right? Therefore, in this case, can you see that n minus 1 factorial is definitely divisible by n plus 1 divided by 2, obviously, right? Because you look at the product, and note, your n plus 1 over 2 must be greater than 1 and less than n minus 1, right? Very obvious. Therefore, this implies that n minus 1 factorial is divisible by n plus 1 divided by 2. That means in this case, when your n is odd, you cannot find a the n such that the sum of the first n positive integers is not a divisor of the product of the first n positive integer. Therefore, to fulfill the criteria of the question, you need your n to be even. Therefore, in this case, now we look at, that means in this case, actually, there's no solution. That means in this case, there's no solution. There is no such n. There's no such n. Therefore, in this case, can I say that this is no solution? No solution to the question, right? Therefore, we look at the second case. The second case, case 2, right? N is even. N is even, right? Then what happened? And can you see that? Let's look at the division. Let's look at the division again. N factorial divided by n plus 1 divided by 2, right? Then again, can you see that you will end up with n minus 1 factorial divided by n plus 1 divided by 2. And can you see that n plus 1 is actually odd? Is actually odd, right? or n plus 1 is actually odd, right? And can you see that can you see that in this case this, it will not give you an integer, will not be an integer. When will that happen? Will not be an integer. That means this fraction will not be an integer. When does this happen? It will happen when your n plus 1, when your n plus 1 is actually a prime. Or that means in this case, will not be an integer. When does this happen? That means when n plus 1 is a prime. Or when n plus 1 is a prime, this implies your n plus 1 divided by 2 is not going to divide n minus 1 and then factorial. Oh, can? Oh, because why? When this is a prime, because you know why? When this is a prime, this prime is bigger than your n minus 1. Therefore, the division is not possible. Because you know why? This division can be viewed as, can you see that when your 2 flip up, you will get what? You will get 2 times n minus 1 factorial divided by n plus 1. Or therefore, if this is a prime, this prime is bigger than, this prime n plus 1 is bigger than n minus 1, which is the largest number, right? Therefore, can you see that definitely in this case, your n plus 1 divided by 2 is not going to be, is not going to divide n minus 1 factorial. All right. Then in this case, take note, note 999 is the largest 3-digit prime. This one, I think you may need to know this, because if you largest 3-digit prime, or largest 3-digit prime, right? Or therefore, what does it mean? That means in this case, actually n plus 1 is actually 997. Therefore, the largest n that we are looking at, right? The largest n that we are looking at is actually 997 minus 1, and that would be 996. Or therefore, I think you need to know this result, that 997 is the largest 3-digit prime. Oh, yeah. Okay, with that, I think more or less we solved the question. Oh, right. Or therefore, be very clear in how you actually solve. Okay, will not be an integer. Sorry, will not be. Will not be. Sorry, I think this part here will not be an integer. That means in this case, this part here, let me clarify. Will not be an integer. Will not be an integer. It will not be an integer provided what, class? It will not be an integer provided that n plus 1 is a prime. Therefore, I think this part here, yeah. I think this one, I keep saying will not be, but I think I left out the word not. Yeah. Okay, with that, I stop here.